A solid metallic sphere is positively charged and isolated from all other charges. The electric potential due to the sphere is, first of all, it is given that it's a solid sphere, and I understand solid as not empty inside. But according to the correct answer, it means that it's a sphere which is empty or hollow sphere, so empty inside. And let's review key graphs. The electric field when it's empty inside sphere, and actually here it means that it's about empty inside sphere, and when it is positively charged, field inside the sphere is equal to 0, and outside it changes as 1 over r squared, or decreases or inversely proportional to distance squared. And hence potential, it is given that field strength is negative change in potential divided by change in distance. In general, this delta is derivative, and derivative to be equal to 0, what does it mean? It means that potential is constant, and hence we can deduce that potential within or inside the sphere is constant. Or actually it's not necessary to use the derivative, because change in potential to be equal to 0, it means what? It must be constant, because value minus the same value gives us what? E to be equal to 0 as required. So potential inside the hollow or empty inside sphere is constant, and positive constant when it is positively charged, and hence decreases as 1 over r. When it would be negatively charged, this graph will be just reflected about x-axis or r-axis here. But if we consider solid, it means not empty inside sphere, electric field increases linearly inside the sphere and then decreases as 1 over r squared, and hence E its negative derivative over v, hence v its negative integral, and it looks like a function ax, and integral is what? Ax squared over 2, but it doesn't matter, so it's some constant x squared, and due to this minus it becomes negative x squared, so it looks like negative concave down parabola. Hence inside the sphere potential looks like this, as part of concave down parabola, and then decreases as 1 over r. And for gravitational field strength, if we consider the Earth, if it would be the Earth, gravitational field strength, it will be the same graph but reflected about x-axis or r-axis here, and potential also will be the same but reflected about r-axis. So here A is correct, is a constant inside the sphere. It means this. Is other options is constant electric potential is constant outside the sphere. It's definitely not correct. Is smallest at the surface of the sphere. You can see that if we consider this not empty inside sphere, this point at the surface of the sphere, its intermediate value. If we consider from the center, and r increases not inside the sphere only, but if we consider inside the sphere only, you can see that it decreases from some value to some value. So So when it is positively charged and not empty inside, and if we consider inside only, yes, on the surface it will be the smallest value, but for overall you can see that it continues to decrease as 1 over r, and increases with distance from the sphere. No, if it is positively charged sphere, it decreases, not increases. So here A is correct, and that's all for this question.